This testing aims to showcase the performance of hydrophobic versus hydrophilic foam in excavations with water. Linemen have reported using pole foam in augured holes with excessive water, prompting this examination of both foam types in such conditions. Let's examine the definition of hydrophilic foam and hydrophobic foam. Hydrophilic foam refers to a type of foam material that has an affinity for water, meaning it can absorb and retain water. The term hydrophilic comes from the Greek words hydro, meaning water, and philic, meaning loving or attracted to. In the context of foam, hydrophilic properties allow the material to absorb and retain water within its structure. GRA and BMK foam are both hydrophilic foams. Hydrophobic foam refers to a type of foam material that repels or resists water. The term hydrophobic comes from the Greek words hydro, meaning water, and phobic, meaning fear or avoidance. In the context of foam, hydrophobic properties mean that the material does not readily absorb or retain water. Instead, it repels water. Rainbow's pole-setting foam is a hydrophobic foam. To conduct the test, each 7-foot deep excavation was filled with 2 feet of water before inserting a 10-foot-long pole. Following pole placement, each foam was mixed according to the manufacturer's instructions and poured into the hole. After the foam cured, the pole and foam were observed, and the force required to pull the pole from the excavation was documented. To determine the necessary foam quantity, the volume of required foam was calculated using the volume calculator or charts provided on the manufacturer's website. The input parameters utilized include a hole diameter of 18 inches, a hole depth of 7 feet, and a pole diameter of 10 inches. The websites recommended the following kits. BMK equals 6.72 cubic feet. GRA equals 3.55 gallons. Rainbow equals 9 cubic feet. To establish a benchmark for testing, a pole was anchored in the hole using concrete. Attempts were made to pull the pole from the hole, but the equipment available had a maximum capacity of around 10,000 pounds. For the purposes of the upcoming test, a pull-out load of approximately 10,000 pounds will be considered as fully secured in the ground. BMK wet test. The BMK foam was mixed according to the manufacturer's recommendations and poured into the hole, which had approximately 2 feet of water. Shortly after pouring, there was rapid and excessive expansion, a clear sign of a hydrophilic foam reacting to water. The resulting foam was weak and less dense, presenting itself as a soft foam easily torn and destroyed with a bare hand. Notably, this weak foam failed to anchor the pole securely in the hole, allowing for noticeable pole movement. To gauge the extent of overexpansion, one can compare the amount of foam used in this wet test with the amount used in a dry test. The force required to pull the pole out barely exceeded the pole's dead weight, suggesting that the foam did not effectively adhere or secure the pole in the hole. The below-grade foam also exhibited weak foam as it was damaged by the bare hand. GRA wet test. The GRA foam was mixed according to the manufacturer's recommendations and poured into the hole, which had approximately 2 feet of water. Shortly after pouring, there was rapid and excessive expansion, a clear sign of a hydrophilic foam reacting to water. The resulting foam was weak and less dense, presenting as a soft material easily torn and destroyed with a bare hand. Notably, this weak foam failed to anchor the pole securely in the hole, allowing for noticeable pole movement. To gauge the extent of overexpansion, one can compare the amount of foam used in this wet test with the amount used in a dry test. The force required to pull the pole out was approximately 2,100 pounds, suggesting that the foam did not effectively adhere or secure the pole in the hole. The below-grade foam also exhibited weak foam as it was damaged by the bare hand. Rainbow wet test. The rainbow foam was mixed per the provided instructions and was poured into the hole, which contained approximately 2 feet of water. Rainbow's foam began to rise in a controlled manner, and no overexpansion was observed. Rainbow's foam is the only hydrophobic foam of the three tested. Notice how the pole is secured in the hole. Compare the amount of foam to the dry test for an illustration that overexpansion did not occur. Both the wet test and the dry test used the same amount of foam. The load required to pull the pole out was approximately 9,000 pounds. This indicates that the foam did adhere to the hole and secured the pole in the hole. The foam below grade is strong as evident by not being penetrated or torn by the bare hand. Rainbow caisson. In this test, we demonstrate the installation of a pole within a caisson, specifically addressing situations where the hole is unstable and the excavation walls tend to slough. After placing the caisson in the hole, we inserted the pole and carefully mixed and poured the foam into the hole. Following the curing of the foam, an attempt was made to pull the pole out of the caisson. The test results clearly show that the pole withstood a pull-out load exceeding 10,000 pounds, and the failure occurred along the plane between the caisson and the soil. BMK versus rainbow foam samples. This demonstration involved pouring each foam into a small container containing water. Sample number 8 represents BMK's hydrophilic foam, while sample number 5 represents Rainbow's hydrophobic foam. Observe the clarity of the water in the bottom of the container. Cloudy for BMK's foam and clear for Rainbow's foam. This disparity indicates that BMK's foam has mixed with the water, whereas Rainbow's foam has not. Next, the samples were cut to assess the structural integrity of the two foams. BMK's foam appeared spongy and had absorbed water, which does not offer effective protection against pole corrosion or deterioration. In contrast, Rainbow's foam exhibited strength and did not absorb or retain water. This is attributed to Rainbow's closed-cell nature, preventing water absorption. Poles embedded with Rainbow's pole-setting foam are securely held in the ground, while safeguarding the pole against corrosion, deterioration, and rot. Conclusion. The previous demonstrations aim to highlight distinctions between GRA and BMK hydrophilic foams versus Rainbow's hydrophobic foam. It's crucial to adhere to the manufacturer's guidelines regarding water presence in the hole. Both GRA and BMK recommend that there be no standing water in the hole due to hydrophilic foam's performance in such conditions. On the other hand, Rainbow suggests allowing no more than 2 inches of standing water, as Rainbow's foam is not affected structurally, but the foam floats on top of the standing water and may reduce the foundation's resistance to overturning. If a hole exceeds 2 inches of standing water, consider using Rainbow's Pole Quickset. This conveniently packaged, non-expanding quick-setting concrete material can effectively remove freestanding water. You can then proceed to fill the hole with Rainbow's pole-setting foam or opt to entirely fill the hole with Pole Quickset. Learn more at www.rainbowtech.net.